Hello. So I'm going to show some basic R commands, so just some handy functions of a kind. The very first thing I'm going to show you is a list of operator precedents. So I'm going to treat this like a calculator, and a couple of things you'll notice. You'll notice what's called that it's interpreted. Essentially, anytime I type in a line and hit return, the line executes. It has dynamic dynamic type, which means that I don't have to set any particular variable as being an integer or a numeric or anything like that. So I'll go through a few functions and show you how you can do calculations. Now, we're going to see types in a lot more detail later. Now, some people use this for assignment, and by the way, that executed, so now x contains 3. If I just type x, if you type any object in R and hit return, you actually get the same thing as print. Okay, so it prints what's inside it. I actually like using equals for that. So an alternative is to say x equals 3. Look at x, there it is 3. Another thing I'll be doing for now is writing in a couple of vectors. That uses one of the simplest ways to do that is to use the combine command, C. After that, if you just put some values in, you create a vector. Okay. By the way, as far as names, notice I use X and Y. It turns out you can use any combination of large or small letters, any numbers, a period, or an underscore. And they can be in any order except that you can't start a variable with a number or dot and then a number. And generally, it's going to turn out if you start a variable with a dot, that has a particular meaning that we'll get into later. So I wouldn't advise that just offhand. And secondly, I wouldn't advise using a dot, a period in it anyway, because that will turn out to give could confuse us between variable names and what's called functions with method dispatch, which we'll see later. So I could name anything I want, though. I like underscores. So you put like a sentence, new vector. Here's another one. I can make a integer vector. The vector up here, I'm going to just show a couple types. Those are real numbers. So x is a vector of real numbers. Another thing I can put in are floating point numbers, like, characters, or even integers. To force things to be integers, of course those are integers, but if you want to force things to be stored as integers, you put L after them. So okay. By the way, you can use the up key anytime you want to get lines and if you want to modify them. So I can go up to newer vector and instead add another thing to it, like there we go. And again, if I type any of the names, I'll see what's inside it. The first set of commands I'm going to show you are, let's see if they're right here. Here they are commands that are used to kind of probe variables and see what's inside of them. Class is probably the best of them as far as just generally telling you what type of variable you're dealing with. Structure gives more detail, and if you want to look for specific types, things like is vector, is numeric, is integer are all handy. Oh, reminds me of NAs. Let me show what that is in a second. Where am I? There I am. So for instance, I can say is integer. Nope, that newer vector isn't an integer variable. If I want to look at its class, it's character. Class of new vector is numeric. Class of x is numeric. class of, which one did I put? Integer vector is integer. Okay. Structure tells you a little more. So the structure is, it's an integer vector. It has 3 values in it. There's the 3 values. Okay. By the way, the concatenate or combine function, which is C, can be used to combine 2 vectors. And you're going to see something called coercion right here. What that means is if you do math on 2 vectors or somehow combine 2 vectors and they have different types, it'll try to find a type that they both can agree on. So, for instance, what was up here? New vector was numeric. It was a floating point number, whereas int vector was integer. If I try to put them together, okay, I've actually combined those 2 vectors now. If I look at its class, it's not integer. This is integer. These are real numbers. The only way to put them together is integers can be real numbers, but real numbers aren't integers. So it coerced the whole thing into being numeric. Okay, and it does that automatically. Notice I didn't have to say anywhere what, I didn't have to ahead of time say xy is numeric. It just comes out that way. There's is.dot commands. Those are used for checking various types. So you can say, is something a vector? It is. Is xy integer? Nope. Is xy numeric? It is. Is xy character? No. Okay. All right, so those are all used for checking, just finding out information about your vectors. Another nice one is length, which, guess what? Tells you how long it is. Okay, there's 6 things in xy. See, there's xy right there. Okay, now, we could do a little bit of math here. So what I'm going to do is show some mathematical operators. Where are they? By the way, let me just first tell a couple of really handy commands. Where are they? That you might want to use. Here's just a couple of really general ones. Q exits. So if I type Q and return, I immediately leave the program. I don't want to do that right now. ls tells you all the variables you have. Here's all the variables I happen to have in my workspace. If I want to get rid of some of them, I can remove. So hold's been removed. Let's see. Is that enough for now? I think so. So let's do a little bit of math. Let's look at right here. Oh no, I had it a second ago. Here's all the mathematics operators you can use. And it turns out you probably want to use parentheses when you're doing math because rather than risk it, because it calculates from left to right, but it's going to run operators. If it has any ambiguity, it's going to do the ones higher in the list before it does operators at the bottom of the list. So I'll tell you really quickly what these are all for. This operator is very specific. It's used for if you have a function from a particular namespace, you put namespace double colon the function, and then there's no ambiguity about where that function comes from. These things are for extracting parts of objects. These are for getting indexes like a matrices and so on. So these are very specialized, and they're the highest precedence variables. This is power. Exponent. This is plus or minus, but when used like making a negative number, -2. So it's not a binary thing. It's a minus put in front of a number, like -7 is calculated early. Sequence operator is really interesting. If you put a number before it and after it, it actually creates a sequence of integers from the lower one to the higher one. let me show you that one. That's really handy. So let's go. I want x, y, y to be the numbers from 3 to 10. There they are. Ooh, I wonder what their class is. Let me look. They're integers. Hey. Okay. Okay. Let's go back here. Wrong thing. Where did it go? There it is. I should say these are operators like modulo, which I'll discuss at a different time. This is your typical multiply and divide, add and subtract. They're getting lower and lower precedence, so it's going to do multiplication before it does addition and subtraction. These are logical statements. If you compare two things, it'll either give a true or false. Let me show you this right here. Is 7 less than or equal to 10? True. Okay, so x, y, y, here's a whole vector. If you apply any function to a vector, it applies it to every value in that vector. So if we go x, y, y less than or equal to 10, yeah, let's make it 5, less than or equal to 5, the first three are and the rest of them aren't. Okay, so what other operators do we have? Negation, an exclamation point, it's a logical. So if you have a logical statement, put exclamation point in front of it, it means that won't, it's the opposite. Oh, let's go look. The opposite of x, y, y less than or equal to 5 is, that means not x, y, y less than or equal to 5 is false, 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 and the rest true. Notice it's the swap those around right there.